pain temperature.
Pleasure, no?
Let's see. Pain temperature kind of. I don't get it, what you versus fine touch. Proprioception. What's proprioception? Can I make your skin vibrate?
Yeah, when you're cold. Shakes.
Yeah, it wasn't what I was thinking, but anyway. Proprioceptive is when you can sense the amount of tension that's on the muscle and the with the bones and the muscle and everything else. You know where your limbs are in position because of skin sensors and sensors within the muscle and the tendon of the muscle. See that? So all this information has to be relayed back. Are you guys listening? All this information, this sensory information, has to be relayed back. And then, if you want your brain to interpret it. If you don't want your brain to interpret it, this is the beauty of it. If you don't want your brain to interpret it, if it's too important, right? Like my dumb ass. One day I come in, I put my hand on top of the range without even, because I wanted to see if it was hot. And I put my hand on top of the range, but I put too much weight on it, and sure enough, it seared my hand really badly, right? But when you go to do that, guys, you have an ability to pull back. You can sense when something's hot, you realize it's too hot, and you pull back. It may be too late for that bit of skin, but not for the rest of the skin that's around, in and around it. You got me? So the ability of you being able to sense that something's hot and pull back immediately and not have to perceive that it's hot, you get me? Then that means you're not sending it up. I didn't tell you that I told you all sensory information has to go up. But I remember I told you, there's nothing that says that it can't just stay at that level and come back out for a response and also send information back up. Man, that hurt. Next time you remember, don't touch that, it's hot. Even when it doesn't look hot, it still may be hot. Don't touch it, you see? But you won't learn unless you touch it and get burned. Then you learn. So what happens when you get that reflex? Did everybody hear me? When you get that reflex, did everybody hear me? When you get that reflex response, this is what it looks like. This is called a monosynaptic reflex arc, guys. When that sensory neuron coming in decides to stay and input directly on a neuron, a motor neuron that's going to go out. That's called a monosynaptic reflex arc. Now, what do you think, guys? Do we have a couple of these, or do we have a shit ton of these? What do you think?
A lot.
We got a shit ton of these. You understand me? We got monosynaptic reflex arcs on both left and right sides at every level of the spinal cord. This is the reason why the spinal cord is segmented. You got sensory information coming in, you got motor information coming out at the same level. Sensory in, motor out. Monosynaptic reflex arc. But now let's think about this for a moment. Guys, when I pull this leg up, what happens to this leg? When I pull this leg up, what happens to this leg? It tenses up and it takes on the weight of the balance, right? And then you elicit muscles to contract, right? Well, isn't that the way don't I do that when I walk? I mean, you don't see me doing this, right? Like a Rockefeller, right? You're like one of the Rockefeller dancers, right? No, you see it real subtle, right? So I'm leaning forward. See how complicated it is? You gotta lean forward and then, yeah. But when you do that, you don't realize it. When you do that, you're shifting all your weight onto that leg to allow that leg to swing out. Boom, boom. All right? That's how you're walking. So at every level of the spinal cord, you have these monosynaptic reflex arcs that are coming in at that level and then going out at that level on the same side. Now separately. Guys, when I go to lift my arm, let's think about this for a moment. When I go to pick something up, and I go to lift it towards me, like I'm going to go eat, all right? I can't have this muscle contracted while this muscle's contracted. Do you agree? Does everyone agree? If both muscles are contracted at the same time, where's my arm going? Nowhere. It's staying right out down here. Y'all got me? And remember we said that that in any movement of any bones, there must be two muscles that work opposite each other, yes?
Yes.
Well, if that's the case, then I have to have one being inhibited while the other one is activated. Does everyone agree? Does everyone agree? Yes or no?
Yes.
Because everybody's taking the muscle exam, right? So in muscle, we say when one's contracted, the other one must be relaxed. For my eye to move this way, I have to be contracting what muscle? For my eye to move this way, I have to be what? I gotta be contracting the lateral rectus and relaxing my medial rectus. Does everyone agree? Because if my medial rectus does not want to relax, then guess what? My lateral rectus will contract all it's want. My eyeball's gonna stay exactly where it's at. You understand? It's when one is greater than the other that you get movement. So we have to account for that. Because why? Because it's the nerves that stimulate the muscles to contract. Does everyone remember? If I cut skeletal muscle, will it contract? Nah. It's going to go flaccid. That's it. You're going to lose that muscle. You're going to get muscle atrophy. So the nerve has to be connecting to the muscle. It always has to be there. And the nerve has to constantly be discharging to the muscle to make sure the muscle contracts every so often. That's what we call tension, muscle tension, or muscle twitch. Simple muscle twitch. We have to maintain that. Does everyone agree? We do. So then that tells me that, hey, I can't just be so let's put it up. Hey, do I have oh, no, I'm sorry. Oh, no, that's not good. I gotta make it nice and big. So in my spinal cord, I have monosynaptic reflex arcs. And I asked, well, what type of other reflex arcs do we have? Well, we have one that tells one to flex when one contracts, the other one relaxes. So that means we have to have what? Check this out now. I'm gonna draw it up here on the board for you. So it's illustrated. It's in your textbook. Sorry. So that same sensory neuron that's coming at that level gives a second branch off. But instead it's going to another neuron. Let's say that neuron is an inhibitory neuron. That one's going to the tricept, while this one's going to the bicept. So if I get a certain reflex, I'll get a certain reflex where I can cause my muscle to contract this way. But to get my arm to move this way, to get that muscle to contract, I have to relax that muscle. So I have to inhibit this one and activate that one. Y'all got me? So it's one signal, but two neurons. One going to one muscle, the other one. So look, antagonist versus the agonist muscle. Everybody see that? And that's still on the same side. That's a reflex arc. Well, there's another one. The most complicated of them is this one. I come in and I decide, hey, you know what? I need to go to the opposite side, yo. Everybody see that? I need to go to the opposite side. Because watch now. When I flex this leg, don't I extend this leg? I do it without even thinking about it. You do it without even thinking about it because we've been doing it for so long. You pick one leg up, the next, you don't even see it flinch, do you? You don't see this leg, you don't see the muscles in this leg activate. So what? I flex and extend. So when I stimulate this one, I flex this one, I extend that one. So watch what they call that. They call it the cross extensor reflex response, guys. The cross because it crosses the spinal cord at that level. And what is it? It's activating a flexor on this side, but then activating an extender on the opposite side. So they call it the cross extensor reflex response. Guys, nothing more than what? Monosynaptic and polysynaptic reflex arcs. So we've got all these monosynaptics on the same side, and we got polysynaptics on the same side, and then ones that crisscross one another at each level of the spinal cord. Shit! That's a ton of stuff! Then I gotta connect each spinal cord segment, not only to each other, but to the medulla, travel up the pons, through the midbrain, and to the thalamus. Guys, you got me? Everybody understand that? Now, let's talk a little bit more about these. Because we're almost done, right? What time is it? 10 more minutes?
Yeah.
Okay, so let's talk about this. Ready, guys? Would it make sense, guys, that I would have grouped these up into two groups for a reason? Yeah. So now watch. This is all sensory information, which means information's got to be taken in to the spinal cord. But how this information gets brought into the spinal cord and how it gets relayed up to the brain, all right, so wait. Let me rephrase this. Does everyone agree that if I'm a sensory neuron and I'm coming in, I have a choice, yeah? If I have to relay to the brain. Everyone agree? Either I'm a sensory neuron, because remember, we were talking about reflex arcs, right? But now, separate of the reflex arcs, okay, which are occurring at every level of the spinal cord. Every sensory neuron that comes in has a choice, separate of it working at the level of the spinal cord. Because remember, it still has to relay sensory information to the brain, okay? So it has a choice. Either I can come in at the same level, and go up the same level. Everybody got me? So I could be sensory information that comes in at the level of the spinal cord, and then goes up the spinal cord, travels up the spinal cord through the white matter tracts. And when I get up to the medulla, because I came up at the same level, I have to crisscross. Did everybody hear me? So again, if I'm sensory information, and I have to go to the brain, I have one of two choices. Either I stay on the same side, or I crisscross to the opposite side immediately. Did everybody hear me? I'll say it again. Listen, please listen. Because this is very important. Because there's a lot of information in spinal cord. This is the reason why I didn't assign it yet. Because I don't want you guys going, just like I don't want you to learn about all the nuclei that are in the thalamus and hypothalamus, because you're wasting your damn time. This is not neuroscience. I don't want you learning all the tracts that are in the spinal cord. Do you understand me? There are only two sensory tracts I want you to focus in on, and there's only one motor tract I want you to focus in on. That's it. The two sensory tracts are broken down into what they relay. And when they come in, pain and temperature now, watch. Pain and temperature. When it comes in, if I'm pain, temperature, or crude touch, I'm being relayed in, and I'm going to cross at the level of the spinal cord. Holy Christ almighty. If I'm going to go up to the brain, I'm traveling pain, I'm taking pain, temperature, and crude touch information through these pseudo-unipolar neurons, and I'm going to cross at the level of the spinal cord when I first come in, guys. You hear me? Well, when I do that, look, I go into the lateral white matter tracts. Everybody see that? And I'm going to travel up through white matter. Well, where do I have to go? Well, I got to go where? I got to ultimately go to the thalamus. Does everyone agree? So look, watch. I can write down in here. So let me write. Oh, wait. So I'm just going to put a circle here. And I'm going to write medulla. Okay? Then I'll put a smaller circle that says pons. And then above that, midbrain. And then above that, the diencephalon. And we know that everything's got to go to the diencephalon. Does everyone agree? Everything's got to go diencephalon. So I just all I did was draw the range, the different strata. The different areas that you're going to pass as you're going up. to the diencephalon, to the thalamus of the diencephalon, because the sensory information is going to go there. This pain, temperature, and crude touch has got to go there. This fine touch, proprioception touch, and big touch, got to go there. But how it gets there is what matters. How it gets there. 80% of all the fibers that are going to take pain, temperature, and crude touch, 80%, guys, of pain, temperature, and crude touch are going to crisscross at the level of the spinal cord. They're going to go up into the lateral white matter tracts and be myelinated. They'll go up through, I could be coming from sacral, go all the way up. Doesn't matter, it just happens I'm bringing it through thoracic. These neurons can exist at any and all levels of the spinal cord, guys. You understand me? I just chose thoracic to show this. So please don't think it only happens in thoracic, because it happens everywhere in the spinal cord. The sensory information, we're not talking about reflex arcs anymore. We're talking about getting it up to the brain now. How the brain perceives this stuff once it's in. So once it comes in, it crosses at the level spinal cord, goes up through white matter tract. Sure enough, it goes up the medulla, and at the medulla, guys, I already crisscrossed. Did everybody see that? Am I going to crisscross again? Nope. I'm going through the medulla, through the pons, through the midbrain, and to the diencephalon I go, and those neurons will go out to the cerebral cortex. Those secondary neurons that are in the diencephalon, they'll extend to the cortex. Thalamus receives it, then sends it out. You got me? The other option, the only other option here, for this pain temperature, because I said 80% does this. Well, what's the other 20% do, Professor P? 20% do this. They stay at the level. They come through anterior. They go up to the medulla. They crisscross. Then the second neuron goes up to a third neuron. Everybody see that? Now, I don't care about the number of neurons. What I care about is how they travel. So, guys, what would I call this? Where's it coming from? 0 under E, it's coming from spine. Where's it going? It's going to the thalamus. So what are you going to call it? What are you going to call these fibers that are carrying pain, temperature, and crude touch? Well, you're talking about the 80% that travel through the lateral gray matter tracts. You're going to call those, this is 80%. You're going to call them lateral, ready? Spinothalamic tracts. Very simple. Lateral spinothalamic tracts. And where do they cross, guys? At the level of the spinal cord. At each and every level of the spinal cord. Left and right. It means left is switching to right, and right switching to left at the levels of the spinal cord, on top of these monosynaptic and polysynaptic reflex arcs. You guys, you understanding me? Shit gets complicated real quick. There's a lot of wiring. Any questions so far? Now, what about the other 20%, Professor P? But look at where they're going. They're still coming from spine. They're still going to thalamus. So but they're coming through anterior white matter tracts. So what are we going to call those? Anterior. So 80% lateral, 20% what? Anterior. Spinothalamic tract. And what are they carrying? Pain, temperature, and crude touch. Did everybody hear me? What are they carrying? Pain, temperature, and crude touch. What are they carrying? Pain, temperature, and crude touch. Now, guys, if my anterior spinal thalamics don't cross at the spinal cord, then where will they cross? At the medulla. Everybody see that? So 80% lateral spinals cross at spinal cord. 20% anterior spinal thalamics cross at medulla. And you know what they call that? Decussation. New word, better learn it. Decussation. That's why it's so important that you don't injure your medulla. Your medulla is what? Right below the spinal cord. You injure your medulla. Yo, you're messing with neurons that are crossing at that level. Those aren't the only ones. There's one more. This one. This one here, guys. This one here, the majority of these fibers, almost all of these fibers actually, they'll come in as sensory into the spinal cord. But sure enough, what they'll do, so these guys here, the ones that are carrying fine touch, proprioceptive touch, I'll do them in purple. So watch what they'll do. They're still here. I can draw it right at the same level. They're still here. They're coming in, but watch what they do. When they come into the posterior great horn, they're going to go into the posterior white matter tracts. Then they're going to travel up the posterior white matter tracts. When they go into the medulla, they crisscross. Connect with another neuron that goes up and then over. The ones that I drew here in purple are sensory neurons that are taking fine touch, proprioceptive touch, and vibroception. What do you think we'd call those? We could call them spinal thalamics. What would you call them? Dorsal. Look at where they're carrying. Look at where they're going, guys. They're not going into the lateral spinal or the anterior tracts. They're going into the posterior tracts. So what are you going to call them? The dorsal column. So these are called the dorsal columns. That's what they're called. So sure enough, this information is being brought up through the dorsal columns. And it's crisscrossing at what? It's crisscrossing at the level of the medulla. So what do they call that? Those neurons that are there, those cell bodies that are there, they'll call them the medial lemniscal nuclei. So what do we call this? Dorsal column medial lemniscal pathway. That's what they call it. Dorsal column medial lemniscal pathway. And what is that telling you? Oh, that's telling you if it's fine touch, proprioceptive touch, or vibroceptive touch, then that information that's being sent through everywhere is going to come in, is going to enter into the dorsal columns, go up to the medulla, crisscross at the medulla, then go up to the thalamus. Thalamus will then relay it to cortex. Yeah, guys? These are the only two. This one, the spinal thalamics, and the dorsal column medial lemniscal pathway. Guys, there's only two I require you to know. There are others. I'm not asking you to know any of the others. Just the dorsal column and the spinal thalamic for sensory. For motor, you need to know your cortico-spinal tracts, because that's how I get what? Information from the cortex back down to the spine for the purpose of motor movement. Everybody follow? And we're not done, because the spinal cord's got some extra shit in the thoracic and lumbar, which we'll talk about on Thursday. So make sure you read autonomics, guys, okay? Please, make sure you read autonomics. Because this is like an hour. I did the whole chapter on spinal cord in an hour, or less than an hour. Floating around there. If you have any questions, come see me in my office hours.
Thanks, Professor.
Yes, you're welcome.
What's the point of the crossing?
Good question. So think about this. You want to kind of have a balance of what's traveling on either side of the spinal cord. You don't want one side of the spinal cord to be favored over the other. Separately, it's like the same reason why do our cranial nerves from here above, why does left do both left and right? And then why does right do both left and right? So it's a great question. I don't know why. But what I do know is that it does happen, and maybe our not to question why. It's just to accept it as it is. This is what makes it so complicated when you have spinal cord injuries. You'll get, if I get a spinal cord injury on my left, I get deficits on my right. What the fuck is going on? Because some of the fibers are crisscrossing at that level to the right. So I'll have some deficit on the left, some deficit on the right, even if my injury is only on the left. You understand? It's not it's a great question. I never questioned as to why it happens. It just does happen.
I was just wondering, obviously, like if it's something with your left side, be on the left side, and something with
but that's not the case. But that's not the case.
Why would it have to my left? Why did it have to cross to the right? I don't know.
Because your left brain is dedicated to basically receiving everything. Bye. Have a good day. Everything the left brain is designed to receive everything from the right side, from neck down, or from here down, from the jaw, from right here down.
Right.
Everything that's right side is going to left brain for sensory purposes. Everything that's right side is going to right brain for this purpose. But from here up, it's all mixed match because this is so important.
I got you.
You understand?
Yeah.
So from here down, it just is. And so again, this is because we thought it was simple.
Right.
But then when we get people who had spinal cord injuries, we're like, well, okay, I can understand why they would have motor loss on this side, and I can understand why they would have sensory loss on this side. But why are they getting sensory? Why are they getting this different sensory loss on this opposite side? Because that opposite side crisscrosses, And since it's that side that's affected, then any information that's coming in at that level, so let's say I have a left. See, if I have a left, I'm not affecting my dorsal columns at that level. But I am affecting what? The others, the spinal thalamics at that level. So I'll have, so if I press on this, I still got my 20% of the anterior spinal thalamics. I still have my dorsal columns. Right. So what am I going to see? I'm going to see on the left side. I'm going to see a loss of pain and temperature in crew touch. But the same thing's happening on the opposite side. This shit is complicated, man. So then you imagine a patient comes in, or you come on the scene and you see somebody. And at some point, you're trying to assess them so that when you get them to the ER, they know what the hell's going on. Right. If you don't understand that this shit is complicated and they could have some motor deficit loss here, but that doesn't mean that they're not going to have sensory deficit here. The key is to know that this is what's going on and then to try to figure out, okay, this is what I think it is, or this is what we suspect. And then once you get them to the ER, the doctor will figure it out. Right. But it helps if you guys know what you're dealing with.
Absolutely. Cool stuff.
Good. Any other questions?
No.
Sure?
Okay.
I want to ask
Can we start over the whole thing?
I can't.
That's my question.
No. You don't need to start all over again. You got the outline in the videos. Come on in.
What do you recommend for me to put on my face now that works?
Well,